And hello from the campus of Carnegie Mellon University in Pittsburgh, Pennsylvania. We welcome you to the Software Engineering Institute's webinar series. Our presentation today is Risk Priority Number, or RPN. Depending on your location, we wish you a good morning, a good afternoon, or good evening. My name is Shane McGraw. I'll be your moderator for the presentation, and I'd like to thank you for attending. We want today to be as interactive as possible, so we will address questions throughout the presentation and again at the end of the presentation. To log a question, you will see the Questions tab on your console. Simply click that tab and send in your question, and we will address as many as we can throughout the presentation. We will also ask a number of polling questions throughout the presentation, and they will appear as a pop-up window on your screen. And these will help us drive the flow of the presentation, so please participate in those. Another few tabs I'd like to point out to you are the Materials tab, the Twitter tab, and our Survey tab. The Resources or Materials tab has a PDF copy of the presentation slides there now, and along with a one-page document that reviews our topic for today. For those of you using Twitter, be sure to follow @SEI News and use the hashtag SEIRPN. Once again, it's the hashtag of SEIRPN. And lastly, that Survey tab will appear at the end of the presentation, again as a pop-up window. We request that you fill that out, as your feedback is always greatly appreciated. Now I'd like to introduce our presenters for today. Our first presenter is Ms. Julie B. Cohen, and she has been at the SEI for 10 years. She's currently involved in activities to support and improve acquisition practices in Air Force and civil communities. She leads the SEI support for the Advanced Extremely High Frequency Satellite Ground Systems software effort. In addition, she's a major contributor to the Veterans Health Administration support, to include long-term support of efforts to modernize the VHA's scheduling system. She's also a contributor on other customer efforts and on internal research projects. Our next presenter will be Will Hayes, and he is a senior member of the technical staff at the SEI. He directs lifecycle management support to major Department of Defense programs. Throughout his 23-year career at the SEI, Will has supported numerous commercial, government, and defense organizations, providing consultation and coaching for a wide range of roles. And now I'd like to turn it over to Julie Cohen. Julie, all yours.
Thank you, Shane. Welcome to this briefing on risk priority number. We'll start with a general explanation of what the risk priority number process is, some suggestions for how you can use it, and the suggestions will come from the Department of Defense world, but certainly they're transferable to pretty much any other application, and then we'll work an example. So just starting with a very generic example, if we look at a very simple plot of 4 defects showing importance and cost, which one would you work first? Well, it's pretty obvious that you would work 1 before you would work number 3, because it's more important and it costs less. But would you necessarily fix 1 before 2? And what about number 4? Well, it's the least important. It's also the least cost. So even in a very simple example, you can see that sometimes it's not obvious which defects you might want to fix first in a given situation. Oftentimes, we use severity as a way to define what the defects are. And there are some problems with using severity alone. It often causes users to inflate the severity rating because they really think it's important to get their defect fixed. And the only way they can get it fixed is if they inflate the severity. And so using severity alone can often cause problems with how people rate the severity. The severity may not actually reflect the risk based on the defect, but how much somebody wants to get it fixed. And so RPN focuses on risk exposure. So it allows the team to assess priority using a different way other than just the severity, and it allows risk to be shown from different viewpoints. The user might have one viewpoint, a developer might have another. Different users have different viewpoints. And so RPN allows those viewpoints to be part of the process for assessing the defects and which ones to fix first. You may need multiple views, and it's very important usually to get multiple views because people do have different ways of looking at these defects. And you'll see as we talk about the scales and as we work through the example, you'll see how these multiple views work. So we'll start with just a general explanation. The risk priority number method comes from the failure modes and effects analysis world. And a colleague, Bob Ferguson, also helped us develop this methodology. And at its bare minimum, it's pretty simple. There are three basic areas at which you'll look at to determine the overall risk. The first one is severity. How bad is the impact of the defect? Just what does it actually cause to happen with respect to the person who's writing up that defect? If it's a user, if it's a developer, what's the impact? The second one is occurrence. How often is it encountered? And as well, how long will it take to restore usage of the system when it's encountered? And those combine to form an occurrence rating. And then finally, detection. How easy is it to spot it when it occurs? And I liken this to your car. If you didn't have an engine check light, if you ran out of oil and you didn't know you ran out of oil, it's a totally different situation than when that engine check light comes on, and it gives you a chance to know that you've run out of oil before severe engine damage occurs. So that's what the detection element is about. For a weapon system, these three values may equate to, in severity, what's the threat to mission success? Can I go ahead and perform the mission? Might I have to cancel or only do a partial mission? Or can I go ahead and do it as planned? The occurrence, just as I said before, how often it happens, how much time to recover. Detection generally becomes more important when I'm talking about the areas of security and safety in a mission system. Finally, RPN includes rating scales that look at the severity, occurrence, and detection, and my colleague Will Hayes will describe these in much more detail in the next section. Then you also need scaling values for those ratings, and he'll explain those as well. And then a way to combine these. In the original application of RPN, it was a simple multiplication, severity times occurrence times detection, but you can use a weighted sum rather than just a simple multiplication if that's easier to help explain to the users of this system how these factors combine to get the overall risk priority number or the overall risk to the system. And now we have a polling question for you.
Okay, folks, as I mentioned during the intro, we'll ask a couple polling questions just throughout the day. It's going to help us with the flow of the presentation. So based on Julie's overview, would you like us to explain the basic premise of what RPN is in greater detail, or has what she provided so far sufficient to proceed? So we'll give you about 10 or 15 seconds to vote there. We'll take a look at the results, and based on the feedback, we'll go on from there.
Great.
And I'm going to stop the poll, so I hope everybody has a chance to vote there. And our results are 68% no and 32% yes. So we have a sufficient understanding to proceed.
So I'll turn it over to my colleague, Will Hayes, who will continue with the explanation.
Great. So there's a range of applications that we expect to consider with this methodology. And our colleague in the LA office, Bruce Grant, has helped us to think more clearly about some of the development applications. Our initial experience has been with a system that is in early fielding, and so the kinds of decision points that apply there may differ from an organization that's working on brand new products that are about to be fielded or will be fielded in the future. In a development context, you might be thinking about prioritizing a backlog of defects that need to be resolved in anticipation of your first release. And the risk priority number might help you to decide which defects, if removed, would contribute most to the value proposition your new product offers. As well, you might have a sorting rule for defects that occur during a system test event to help you identify which sets of defects discovered require more immediate, more concentrated attention, and which defects might be postponed for later examination because of the need to continue in the testing regime. So as we think about applying these concepts in these variety of applications, there are a number of key points that we've uncovered through our experience that contribute to success. One of the most important things in applying something like this is to adequately harness and understand the local knowledge that exists. As we think about attributes of the system, knowledge of that kind of information is essential to being able to triage or to make reliable judgments about the impact a defect might have. And so these scales help you to quantify that and make that a much more explicit thing. But that wouldn't be possible without involving people who have a deep knowledge of the system. Also, the communicating of preliminary results is one of the most important aspects of maintaining the momentum that you establish by involving the local staff. And then finally, as you come to preliminary results, if you're able to show the progression of evolution that you've seen in the methodology, that helps a great deal in getting people to understand and buy in to the activity that you're engaged in. So we'll dive into a very specific example here, and Julie will follow with a quantitative set of information that allow you to see how the numbers play out. But what we want to do here is kind of lay the foundation. So the system that we've got initial experience in, they were planning upcoming releases using a set of discrepancy reports or defect reports that exist against a system that is in the early process of fielding. It has a broad set of missions that this system needs to support. There are a variety of different user communities, each community with a potentially unique usage profile for the system. And so the kinds of defects we encounter will be sensitive to the usage profile. And so if this defect affects something in my usage profile, I'm going to be very motivated to see that it gets resolved. But if this defect doesn't apply to something that reflects my workflow, then I might be less concerned, or I might have a difficult time seeing how severe its impact is somewhere else. And the idea here is to find a way to make that an even playing field with people that come from different perspectives and have different priorities. And one of the important aspects of our initial experience was the program office's engagement. The program office in major contracts or major systems of the type we're talking about has a long and broad view of investment and utility that you really need to have in applying something like this, because the long-term decision-making process is affected by how you prioritize what's worked on today. Going on to the next slide, speaking about now this sequence of events that we orchestrated as we piloted these concepts. The first thing, I will repeat again, the importance of local knowledge. So getting representatives from the diverse user communities, from the different stakeholder groups to participate as a member of the working group was an essential ingredient to success. Again, the program office's long and broad view to be able to help people understand beyond the next release or beyond the next profile of utility, what's the long-term evolution in mind for the system. And then a coach, someone who helps to kind of listen carefully to the local knowledge and really channel that into a set of measurement scales that can result in consistent judgments being made and good decision making being supported. And finally, establishing agreement at the working level with your initial take on how to approach this is really essential, because you want people to go forward with agreement that we've captured a set of knowledge that is good to build on as a starting point. Let me go to the next progression then. With that initial set of draft materials, we were working for a very smooth transition. We wanted folks to be involved and to offer adjustments to the methodology, to propose alternative ways of weighting different components, or to experiment with different scales. And the development of spreadsheet tools and quick ways of using forms to get feedback was really essential to letting people make adjustments and then telling people about those adjustments in subsequent meetings and letting them see the kinds of influence the user community or other stakeholders could have was important. And this demonstrated a respect for local knowledge and the need to use that knowledge to implement what we're talking about. And then finally, there is nothing more powerful than actual data. So looking at past defects that have been removed and resolved and applying the proposed algorithms with that data allows us to then feed back, here's what it would look like had we used this methodology at that time. The experience of the people from that past event allows them to make good judgments about whether or not the methodology is serving them well going forward. And so those are some of the keys that we found to having a successful pilot and rollout. Now I want to talk a little bit in more detail about the content of the scales and the methodology itself. So Julie is going to follow up with scenarios that have fictitious data against these scales, and so you'll be able to see further how this plays out when she begins her section next. So the scales that we constructed with this pilot experience, remember there are three primary components: severity, detection, and occurrence. In the group that we were working with, it seemed to make good sense, and our piloting and our trial runs with the data supported this. It made sense that severity was most heavily weighted, and detection and occurrence were equally weighted, each at 20%. And in this case, a weighted sum was chosen instead of a product multiplying these together. But that's a nuance, a detail you may not be as interested in. The severity scale now is made up of a number of different components, and the operational impact, given the nature of the system and the experience of its users, operational impact was viewed as the most important consideration in judging the risk inherent in allowing a defect to persist in the system. And there are a number of other components that make up severity, but we'll speak in more detail about each of those now. So this first example scale, and a shout out to Kurt Hess, who is our graphics artist, who does a marvelous job with these things. I think most of us can relate to the notion of an automobile and how well it serves us. If you've driven a car, if you've owned a car, you understand that first level displayed on the slide, a minor system malfunction. You've experienced probably a flat tire or backfire, something that perhaps doesn't completely prevent you from doing what you need to do with the car, go shopping, go pick up your children, or whatever it may be. All the way to the highest severity scale, you see there at the bottom a car with its doors off and the wheels have come off, and we've seen some of those vehicles as well. You can relate, I suspect, to what's going on here. As well, you probably know the difference between a malfunction that you can cope with and a malfunction that requires intervention of a mechanic. And so that sort of threshold in understanding the malfunction that's inherent in the system because of a defect, the knowledge of the system and the user profile is really essential for consistent judgments along these lines. So here is an example of a scale for severity that we used in our pilot activity, and it's one of a number of different scales. Moving on now to a scale relating to severity. This one relates to operational impact. Again, the most heavily weighted component of risk priority number based on our pilot experience. That may not be the case in your situation if you choose to use risk priority number, but just want to caution you to be aware of the connection to the nature of the system here. So this lets you talk through what is it that's causing the issue that this defect causes. And if you've ever written a discrepancy report or a defect report yourself, there are a number of elements to the write-up that make it have weight or may let it be dismissed. And so these kinds of differences, as you talk about, it may increase the workload of the operator slightly, or it is certain to cause a mission failure. The conversation that instigates, that you have about the defect, is really the essential component here. Okay. Moving on, I have two more scales. Here, the detection scale. One of the things we want to alert you to here is that safety and security issues are particularly important to think about with respect to detection. If you're unable to see that there is an issue with the system, so look at the bottom point on this scale, number 5. This shows the system is smiling at you like everything's fine, but in fact, behind the scenes, there's something gone awry and you're not able to know it. In contrast, the lowest point on this scale is there's an explicit alert or warning. So that is the light coming on the dashboard of your automobile saying there's an issue you need to pull over and deal with, or there's an issue at some point you need to put more fluid in the windshield wiper reservoir, those kinds of differences. Again, detection for security and safety kinds of issues becomes a very important opportunity to avoid being blindsided if you're able to think through these kinds of concepts as you're looking at your defect reports.
And Will, people may be wondering now, the last 2 slides both had ratings 1 through 6, and this one only has 1 through 5. And so we should just point out that the number of levels that you choose will depend on your system and what you're looking at. They don't all have to be the same. You could use 1 through 6, you could use 1 through 5, you could use 1 through 3, if that's easier for the group of users that you're dealing with.
Great, thanks for that, Julie. So we'll move on to the next scale, the occurrence scale. And here there's an interesting pairing of how long does the defect disrupt the operation, as well as how frequently does the workflow supported by the system encounter that defect. And so a small problem that occurs every other minute can be a very severe issue. A major problem that occurs only once but has an outage for a very long period of time could also be a major issue. In some contexts, those 2 scenarios have an equivalent impact. In other contexts, they may be different. In the pilot experience we had, we found a good way to combine frequency of occurrence with the amount of time required to restore the system back to the original point. And so there's an example scale here. Okay. So we next have another polling question. Shane?
Okay, so polling question number 2, and I should have mentioned this earlier. These polling questions, obviously, we have to go with majority rule for, in regards to time. So that's how we'll dictate where we go. So we have discussed 2 scales that equated to severity. You could use additional scales for other forms of severity, and you could use also multiple scales for detection of occurrence. Would you like to see more examples of these type of scales, or continue with how these scales are used? So your options are more examples or continue on. And we'll give you about 15 seconds to vote. And while we're waiting there, how many current customers do you have using RPN? Or are you looking for more people to pilot this? Or what's the status there?
So we're looking for people who are interested in piloting this. We're still working with an initial customer on using this. We have a couple of others who have expressed some interest, but we're always happy to work with other customers who think this might be useful in their context.
And the white paper that's referenced in the slide set, there's a URL for it. That'll give you a set of details that correspond well to the example that Julie's going to walk through if you want to talk with others in your organization about what we're talking about.
Okay, so let's get to our results. And 79% would like us to continue on. So I will share those results with everybody.
Okay,
we
great.
can proceed.
And so in the backup slides, part of the package that you'll be able to download, there are other scales available. Those are the things we would have covered had we decided to divert to that. Okay, so moving on, talking a bit about scaling. And this is a place where the measurement coach can really be of great assistance to you. It turns out that humans, in trying to make consistent judgments, comparing things, have an easier time making those judgments consistently when the scale in which the differences are expressed is something perhaps like a geometric progression, similar to what's shown here. It's easier for me to consistently judge if something is twice as long or twice as large as another thing than if I have to make some more fine-grained distinctions of is this 10% greater, 15% greater. And for that reason, what we've done with risk priority number and what's usually done with it is to use a consistent proportional scale like the one displayed here, which is in contrast to the ordinal scale of 1 through 6 shown all the way on the right. The idea is for us to decide on these anchor points based on things that differ by these amounts. If you want to follow more on this, there's a great book by a gentleman named Douglas Hubbard called How to Measure Anything, which has inspired a great many folks to think along these lines. Okay. Moving on now, this is the expression of the formula that we used, reflected in the chart we saw earlier with the different sized bubbles. So the result, the risk priority number, is computed using this written out equation. And the scale in this case ranges from 0 to 2,400. And so a risk priority number could be as high as 2,400, could be 0. There are issues relating to the scale. If you want to pursue that further, we have another follow-up polling question to ask, and just go right to that.
Okay, our next polling question, which I will pose now, asking, would you like to discuss the use of proportional scales and ways to combine the scales, or continue with the discussion of how to use RPN numbers? And our options, again, are more discussions on scales, or continue with how to use RPN numbers. We'll take about 15 seconds to vote for that. While we're voting, let's get an audience question here. And this was from Tom for Julie and Will, asking, could you please address what I call the swarm of flies problem, where a large number of minor, low RPN defects that accrue over time can have a large aggregate impact on a project that is much larger than any single defect impact. Often, out-of-control projects must address the minor defects first in order to really see the state of the project. I don't see how the RPN approach would help this situation. How would we address that?
So one way to address it, you'll actually see in the example where we look at grouping things by functionality, or you could group them by a CSC or by a CSCI if that's appropriate, so if you're in development. So you can group things in many different ways, and if a group of defects ends up with a very high RPN number as a group, then you may want to say, we need to address this group. Or if there are defects that are blocking you from continuing development or from continuing test, they may have a low RPN depending on how you have structured your RPN. But if they're actually blocking you moving forward, then maybe you need to reconsider your RPN scales and make that a little bit more important. But certainly you can look at blocks of defects together instead of single defects one at a time, if that's more appropriate for your situation.
Great. Will,
So I think Tom's question is a good one. It shows that perhaps the number of lines of code required to address a defect or the length of the paragraphs required to explain it isn't always going to be directly tied to the risk inherent in allowing that defect to persist. And so it may be that a group of quote-unquote small defects could conspire together to create a bigger problem than one large defect that's on your list. So great question. Thank you.
Yes, great. Please keep the questions coming. The audience has spoken. 62% would like to continue with how to use the RPN numbers. And
Great.
I will share those results now.
And so pass it back to Julie.
All right, so the first slide shows the resource. There is a white paper that goes over an example in much more detail than we can cover in this webinar, and you can feel free to look at that if you need more information. So for the sample I'm going to go through right now, we have 3 users, A, B, and C, with 10 DRs each, and we've looked at 5 functions that we've called communications, navigation, planning, propulsion, and security. We're going to assume that the DRs will be fixed in increments of 3,000 source lines of code, or SLOC, and in this case, SLOC really is just a proxy for cost. So if you don't use SLOC, don't think that this doesn't apply to you. Any term of effort measurement that you use, any term of cost effort that you use, that can be substituted for SLOC. In this example, that was just an easy way to express this. And even with this small sample, there can be hundreds of combinations. So first, just a very quick look at the sample data plotted out. And you can see in the lower right-hand quadrant, these are the defects with higher impact and lower cost, and that might be a place to start. But it isn't always that simple, and so we've developed 4 analysis method, and don't think that these 4 are the end-all and the be-all. There could be other ways of doing this analysis based on your specific situation and what's important in your specific project. But the 4 analysis methods we came up with was to look first at functionality. Another way to do this is to look first at system risk. You could start with user ratings if your users are extremely important and you want to make sure that they know that their needs and wishes are being thought about. That could be the way you start, or you could use a hybrid method. So I'll walk through each one of these in a very simple example, and I know that the numbers have been simplified, but hopefully this will give you a taste for how this methodology can be used and what you might be able to get from following this process. So first off, the functionality method. So we just looked at the 5 areas of functionality, how many DRs there were in each one, the total slot for each one, and the total RPN. So the highest RPN areas are communications and navigation. And again, if we assume the 3,000 slot per build, you could close all the DRs in the communications area in the first build, but you would need to do a partial fix of navigation. And in fact, you couldn't even do a full build of any of the other areas as well. So you might as well go to navigation next. And this looks at the specific DRs. And if you're very quick with your math, you'll see that where I've drawn the line is actually 2,800 slot. And so yes, you could, I've actually done the math wrong. It's not exactly 3,000 slot, and you could certainly add more, add some smaller DRs to fill out your 3,000 slot. But you get the idea. The idea here is you start with all the communication DRs, you then would go to the navigation DRs until you run out of room, and that would be your first build. All right, the second analysis method is system risk. And in this one, it's pretty simple. You look at the DRs with the higher RPNs first. And this is often used when you're in a maintenance mode. You really want to try and burn down the high-risk DRs first. And this is a case where you might want to group. As the question asked, what if I have a bunch of small ones that together form a higher risk? If you've got an awful lot of DRs, you may want to group them and pick the groupings with the higher RPN. In this case, though, the top DRs, just looking at RPN first, you could do the first 5 DRs, and this includes some of the top 3 priority ones. It includes a lot of different functionality. It burns down about 40% of the system risk. And again, it doesn't add up to exactly 3,000 slot. You could add some lower priority ones to fill out that 3,000 slot if you wanted to. Okay, the third analysis method starts with the user ranking. And in this one, the blue diamonds show the top 3 rankings. The red boxes show priorities 4 through 6. And then finally, the green triangles show the lower 3 priority ratings, 7 through 10. So we'd want to concentrate on the blue diamonds first. We would want the users to know that we cared about the way that they had ranked and prioritized their defects, and that we were going to start with their highest rated defects. So again, if we look at the list, we could actually close the top 2 defects for each user and still stay under our 3,000 slot cutoff. I believe we're at about 28.5, and so we could find 100 slot DR somewhere to help finish off the 3,000 slot limit if we wanted to. But again, in this case, you can see there are a lot of different areas that we're touching. And in some cases, you may not want to do this because that touches a lot of code, it creates a lot of testing. And so because of those impacts, we developed the hybrid method, which I'm going to show you next. So in the hybrid method, you start just like we did before. We start with the user ranking. In this hybrid method, again, you could start with anything you wanted. In our case, we were looking at a system where the user input was very important. And so we started with the user ranking, and we looked at this and we said, well, okay, we've got a lot of different areas and we really want to try and be a bit more efficient. So what could we do? And when we look at the entire list here, you can see that there are 2 propulsion DRs in this list, but there were only 3 propulsion DRs in total. So if I go back to the original breakout by area, there are only 3 propulsion DRs. And since 2 of those made it into that top list, you may just want to start with the propulsion DRs, and the slot for that is only 1450, so you might consider doing those first. You could then add in some of the navigation DRs and still be under the 3,000 slot budget, and I'll show you that next. So when we add in the navigation DRs, we can still do a fair amount of work, but we've limited it to propulsion and navigation instead of trying to do all the areas in the original user ranking list. You may ask, why did I add in navigation and not communication? Because the communication DRs had the highest RPN. Well, the reason was because navigation had more DRs on the top 10 list. So we wanted to look at those next. Could you have gone to communication next? Absolutely, you certainly could have.
So if I could jump in here, this is a nice illustration how the idea is to provide a measurement strategy that supplements and aids in the decision process, not one that replaces it. So those local priorities and the business decisions to be made, if you think in a new development about to be fielded kind of system, understanding what you're going to have for initial operating capability based on these kinds of functionality trade-offs may be what you're focused on. If we focus on this set of DRs, it will allow us to stand up the full capability of this component of the system or serve this set of users more completely. And our strategy for deployment of this system then can be tuned according to what sorts of functionality is going to be ready in what sort of schedule.
Thank you, Will. So that was a very quick run through the example, and if folks have questions, you can certainly type those in and we'll answer them. Some other uses. This certainly can be used in a development environment, as Will mentioned at the beginning. Severity might be related to the DRs that are blocking test or the number of interfaces to other units. Detection would still be based on the ability to know that it's occurred. The time element could actually be based on the effort needed to correct the defect. And RPN can still be looked at with respect to functionality and total cost to fix. So in a development environment, you could still use this. You would need to tailor your rating scales. You would probably need to tailor your weightings, but you could still use the same methodology. It can also be used very effectively in maintenance environments. The rating scale development could be very similar. If you're in maintenance, you have operational users, and that might be a big part of what you're looking for as far as the impact. It could also be, though, the cost to maintain. If you have certain parts of the code that are more costly to open up and to test and to fix, then that could be another area that you might want to look at, trying to fix defects in those areas and try and fix those early. So you can use this in other areas other than just when you're in an operational use. Some suggestions for DoD usage. Again, this is a lot of what Will already talked about. Very important to develop a team to put together the structure for RPN usage. You really want to be sure to have the proper stakeholders on this team. Certainly if there's a program office that's running the program, if there's a using command, if there are different users, you want to be sure that you have all those users as stakeholders. Each user may bring a different perspective to the table. If the contractors are involved, you would want them to understand what you're doing and why you're doing it as well. And as we talked about, what you would need to do is you would need to develop those definitions for severity. And you could have different categories for severity. We showed you two. As Will pointed out in the backup, there are several other ways to look at severity that you may want to consider. You would need methods for dealing with occurrence. Do you just do time to restore? Are there recovery things that people can do? Are there workarounds that people can do that might impact that? And how do you factor those things into an occurrence measure? You would need to think about that. And then you'd also need detection. You would want to think about your scaling factors, and in relation to the scaling factors, you might want to think about your computation methods. You can use the scaling factors to weight things differently, but that's often harder to explain to your user community. And so you need to sort of balance how easily you want the user community to understand versus how much math you want to try and put in. Finally, you have to think about your data collection methods. Most people already have some sort of a form that they use to collect defect data. This could be added to that form. If you're doing it online, it could be made even easier. And then finally, your process for looking at those RPN values and how you're actually going to do the analysis. Who will provide that analytical support and how those things will be used. And I think we've reached the end of the main presentation, and we're ready to.
Yeah, so we're going to open it up to questions here. So feel free, if you've got questions, feel free to type them in now. We're getting a number of questions on if the slides are available and if an archive will be available of the presentation. A PDF copy of the slides are in the materials tab now that you can walk away with today. And this event, of course, is being archived. Most likely it will be available at some point tomorrow, and there will be an email that goes out when it is up and ready, and it will be the same login that you used today. So let's just jump right into our questions. From Ed asking, can you explain how user priority can be high but RPN low?
Oh, so a user may have a particular profile for usage of the system, and that profile may be fairly unique to that user. And so what is very important to them may represent a small amount of the total space in which defects occur. And so because they are a specialized user, their needs may rise higher in their view than the rest of the user base that might be a more diverse, a more shared set of functionality than that user community has in mind. Is that anything to add?
Yeah, also, there can be times when there is a defect that takes a lot of time for that particular user to fix when it happens. But maybe it only happens once a quarter. So if you think about security updates, and every time you do a security update, you have to reboot the system because the security update doesn't install correctly. So for the user that's actually installing that update, right, that might be their highest priority because every time they do it, they have to reboot their system, and it's a pain for them to have to do that, and it takes them a half a day to do it. But if you look at the fact that it only happens quarterly, you know exactly when it happens, so it's easily detectable, the system has crashed, you have to reboot it, then the RPN may be low, but for them, it takes a person time to actually reboot, the system goes down, and they may think that it's important to them to get that fixed. But the total risk to the system may be lower. You know when it happens, you can predict that it's going to happen, you can plan for it, and so total system risk may not be very high.
Okay, great. Next question from Siva asking, RPN itself, as it suggests, is based on the risk and priority. How user priority would be different from RPN method? Let me repeat that one more time. RPM itself, as it suggests, is based on the risk and priority. How can user priority be different from the RPN method?
So I'll start with that one, Shane. Many times the users aren't really thinking about the overall risk to the system. They're either thinking about their own workload, they're thinking about the risk to their particular mission and not necessarily to the entire system. And so they have a very specialized view. And so just as I talked about before, if it's somebody's security update, to them, that is a high user priority. But it may not be as high an overall risk to the system as another user's defect where you can't tell when it's happened and you would actually have to cancel an operational mission if that risk were to occur. And so oftentimes, how it impacts a specific user may cause them to say, this is a really high priority for me, but the overall risk to the system may be much smaller.
So there may be risk associated with the workflow of the particular user community, and I think Julie's alluding to this as well. If I have a step in the process that tends to be staffed by junior people or tends to have visibility to external parties, even though it is a minor glitch in the system, because that is a part of my workflow that I feel is a higher risk than other parts of my workflow, a defect that affects that support for my workflow from the system might be a higher importance to me to have resolved than it would be for someone who doesn't have my workflow in mind as they're looking at this defect.
Okay, next from Sean asking, how would you apply RPN to measuring / monitoring engineering performance metrics such as defect density and defect closure rates? I'll repeat that one more time. How would you apply RPN to measuring or monitoring engineering performance metrics such as defect density and defect closure rates?
So when I think of engineering performance metrics, I'm thinking of slightly different than that. And this is an area where our colleague Bruce Grant has offered some examples as well. You might have a performance requirement for a component of the system and a performance requirement for the system overall. And you might have a defect that causes a time lag or some performance degradation at the local level, but your budget for performance at the system level can still accommodate that. So even though there's a communication delay on this step of the process, because the overall system performance with respect to communication is ahead of your performance, that may be a trade-off you're able to make. And so the risk presented by that defect needs to be considered in light of risks associated with this system of interacting performance measures. In terms of defect density, do you want to try to run with that one? Sorry.
So I think that really the only connection to defect density would be that as you have defects, if you have RPN, you can tell what the overall risk to the system is. And as you burn down the higher RPN risks, you will burn down more of the overall system risk. And so instead of just showing a defect density, you can now get a little bit more in depth as to, instead of just trying to burn down overall defects, you could actually burn down higher priority defects first, and therefore lower the risk, the overall risk to the system, faster than just picking up defects one at a time by some other method. This will give you an insight into how much risk that particular defect poses to the system.
Okay. So we've got 3 more questions in the queue, so if you have questions, feel free to type them in now. From Bradley asking, is there an analog for opportunity priority number? Have you considered extending this from risks to opportunities as well? And I can repeat that one more time. Is there an analog for opportunity priority number? Have you considered extending this from risks to opportunities as well?
So we haven't. I wouldn't see why you couldn't. I wouldn't see why you couldn't do an opposite scale to say what the opportunity would give you, what advantage would it provide. So are you looking for a cost savings? Are you looking for a time advantage? So you can have severity. Instead of severity, you would have opportunity. I'm not sure how much detection might be. How visible is it to the users that you have advanced this opportunity? The occurrence might be how often this opportunity could be taken advantage of. And so, yes, I think you could. We haven't thought about it, but that's a very interesting idea. Thank you.
Yeah, that is a natural linkage. Thank you for making that, because it really is about a value proposition. And the original formulation, it's the value associated with improving quality by removing risk. And you're talking about value associated with deploying capability. Well, that's the same thing in some sense. If you think of concepts like weighted shortest job first that we see in the Agile world, that's the same kind of thinking that we're doing here. If you think about that disruption metric of how many times does it occur and how long does it disrupt our operations for, that's very much a similar kind of logic as you see in weighted shortest job first.
I always say we have the smartest audience. So,
yes.
Next one from Jim asking, is there any consideration given to dependencies between DRs? From Jim asking, is there any consideration given to dependencies between DRs?
So not a priori, right? Each DR is written up separately, but in truth, you're absolutely right. In any system, there will be some dependencies between DRs. And so, again, depending on your system, if you tend to have a lot of these connections, you may want to group the DRs together and do risk priority numbers for interrelated groups of DRs. If solving one DR is only going to solve half the problem, and by solving that DR, you're really not going to reduce the risk as much as it looks like you're going to reduce it, then certainly you would need to combine those together and do a combined RPN number for several risks that naturally would fit together. So good question, good point.
Yeah, and in thinking along those lines, I would caution against trying to alter the formula or the weightings of RPN to account for that other compelling reason why things belong together. That compelling reason has merit on its own. And please, as you saw Julie work through in the examples, please include that in the analysis. Don't try to load everything into RPN.
Okay, great. Next question from Manny asking, are there examples of how RPN might be implemented using multiple criteria simultaneously to identify the DRs to work on? For example, user rating, functionality, and risk.
So we haven't gone that far with the process yet. I think the closest is the hybrid example that we work here in the white paper. But we would love the opportunity to start to go down that path with an organization. So if you're interested in trying to explore that with us, please, there's a contact slide at the end of the slide deck. Please let us know. We would love to explore that with you.
Okay. We're down to 2 questions in the queue, so feel free to type in. We still got about 10 minutes left. Otherwise, we can always wrap up a little early. A 2-part question from Siva asking, in your experience, have you come across a situation where the team might have possibly ignored most important risks while focusing so much on computing the RPN? That's the first question. And number 2, how do you decide the minimum number of risks to be addressed? Based on RPN, in other words, how do you define the cutoff number for RPN?
So as far as ignoring the risk while computing RPN, I think the idea is to make RPN simple enough that while you're filling out whatever the normal defect form is, that it doesn't take any longer than 5 or 10 minutes. The other thing that we saw with the group that we were working with was that the discussions around the severity rating could be very contentious. It went through several rounds, and people said, oh, I don't believe that it's really as severe as you thought, and why is it? And somebody else did analysis and came up with a different answer, and then the user felt like they had to defend themselves. And we feel that this can really help that process. So if you have any type of a process where these defects are adjudicated, that having this extra information on why you feel it's as important as it is, why you feel the severity is what it is, if you can't detect it, that automatically helps somebody understand, well, if you can't tell when it's happened, and you have to walk through 5 more steps until you know that you had this defect back there, and so 2 more hours have gone by before you even realize that you had the defect 5 steps ago, it can really help to explain to somebody how you came to that severity rating. So we believe that this can actually help in the overall adjudication of DRs. But absolutely, if you make it so difficult that to do the RPN takes away from actually writing up the DR or fixing it, then that's not the way to go.
And I think this is another opportunity to repeat something that Bob Ferguson has told us many times. It's about the conversation. It's about structuring that conversation so people can have objective criteria and know what it is that's leading to the decision outcome that's happening. It is not about getting to a precisely accurate number to 4 significant decimals. As much as I might enjoy that as a statistician, the idea here is to structure the conversation to avoid the condition the questioner asked.
And what was the second part of the question?
Oh, you know what? Let me go back to it. Okay, part 2 was, how do you decide the minimum number of risks to be addressed based on RPN? In other words, how do you define the cutoff number for RPN?
Right, so that generally is formed by either budget or schedule in what we found. Generally, people want an increment delivered by a specific date, and so the amount of work that you could get done in that time frame would be how you would base your cutoff, or how much resources you can put in to the next build would determine your cutoff. And so that's really not determined by the RPN number. Generally, it's determined by a project constraint.
Okay, great. Last question in the queue, so if you have any last minute questions, feel free to type them in. Otherwise, we're going to wrap up on this one from Hemant asking, where do you see being used in the SDLC and operational maintenance processes? Where do you see this being used in SDLC and operational maintenance processes? Will it be mostly for deciding which defects to fix in a system?
That's a very natural place to use it, is deciding which defects to fix. But as I just discussed, I think it can also help in the conversation as to why defects are important, why a user feels like this defect is a top defect. So it can be used in the adjudication process, and then also it will be very useful in deciding which defects to fix first. Again, it may not be a straight, number them by RPN and go down one at a time, starting with the top one. You may want to group them into functionalities to get some testing advantage or some development advantage. You're not opening the same code over and over again. But it certainly is a good guidepost to start out with, trying to take the highest RPN defects first, thus reducing the greatest risk to your system. Will?
That's great.
Okay, Will and Julie, you're off the hot seat. Thank you for your excellent presentation. Again, folks, thanks everyone for attending today. We do request that you fill out the survey upon exiting, as your feedback is always greatly appreciated. For any of those of you having some bandwidth issues today, this will be archived. We'll get an email out tomorrow, the next day, when that is available, and you can catch up then. But again, thank you for attending. Have a great day, everyone.